Okay, hello everybody. This is Brian again. So I'm going to attempt to solve problem 5.5, which states verify equation 5.6 by writing out 321 and I said 3 by writing out C21 and C13. So I wrote out equation 5.6 here. This is what we're going to use to plug our numbers in. So substituting 2 for L and 1 for I, we get this right here. With that, we need to find all the epsilons that are non-zero. And that's pretty much when epsilon equals either one of these sets, when ijk equals one of these sets of numbers, and this becomes 1, or one of these sets of numbers, and this becomes a negative 1. So since we're forced to start with 2, we're going to go through and pick out all the combinations that start with 2, which is 231 and 213. And since we have a second term here, we're going to have to also pull out all the combinations that start with 1, which is 132 and 123. And we want to get all the permutations of that in our summation here. So 231 and 123, since we know we have to include all of them. And 213 and 132 are also added in. The M values are just a simple plug and chug here. So since we have M sub mj, I just pulled the m value here and the j value here, and this becomes m33, and etc. for the rest of this. So these epsilons will equal either 1 or negative 1, since the ones that are equal to 0 are not shown because they don't matter. And the way I do it is I sort of just track which way my pencil moves without counting the uh jumping from one side to the other. So like for example, if I see epsilon 1, 2, 3, if I'm counting from 1, 2, and 3 on the indices here, then my pencil's moving to the right, and that is a positive value. For example, if I have here's a good one. Three, if I have 2, 1, 3 here, if I go from 1 to 2, that's moving to the left. 2 to 3, since it loops, still to the left, so I know that's a negative 1. And that's just the way I keep track of it. I'm sure if you have your own way to do it, it probably works a little better. That's what works for me. Okay, so once you combine all these terms, which I've done here, you eventually get two of each M and M combination here. The one half will cancel these twos out, then you finally come up with this right here. I reshuffled it because I watched Andrew's video and I just wanted to put it in the same format he got. So you can just move this over there and this over here and this over there and that over there, and you get this down here, which is what Andrew got. The cofactor is defined as the determinant of the matrix obtained by eliminating the row and column in the matrix that contains the element and then multiplying by 1 or negative 1 according to the position of the element. So using that definition, or at least partially checking it, you see here that I drew a little matrix. So C21 would be right here where my pencil is. So I crossed out that row and crossed out that column. And I see I have remaining M1, M12, M13, M32, and M33. And that's the terms I currently have in here. For me, that's good enough to call it verified because I could solve that small square matrix, but I feel like this is already the solution written out right there for it. So the second half of the equation has us do it again, but this time for C13. This time I just pulled the one half and I put it over here so I didn't have to write it over and over. Eventually we'll get down to the bottom anyway and it cancels out with the twos, just like last time. Um, Once again, you find all the epsilons that matter. The ones that don't are left out. And you write your correlating M's with those epsilon indices. At the very end, once again, we have C13, so 13 is right here. Let's cross that out, cross this out. I'm left with M21, which is right there, M22, which is right there, M31, which is right here, and M32, which is right there. That's good enough for me personally to call it verified. Now, think that covers this question. So I'm going to move on to the next one. Good luck, guys.